Hello, this is the genuinely approachable Sudoku for the 20th of January 2024. It is Trapper Lines by Philip Newman. So, normal Sudoku rules apply. Digits 1 to 9 in every row, every column, and every 3x3 cage. Sorry, not that cell. Killer. Digits in cages cannot repeat. Well, we already knew that because they all reside in the same row, column, or box. And must sum to the total given. Therefore, say these 3 digits must have an 8 in it. These 5 digits add up to 24. Wait, what? No. These 3 digits must sum to 8. What am I saying? These 5 digits must sum to 24. These 5 digits sums to 15, and so on. Zipper. For each line, the digits in each pair of cells an equal distance away from the center sum to the digit in the center. So there are lines inside these cages. I guess that's why it's called trapper lines, because like the zipper lines are trapped in the killers. So digits in each pair of cells an equal distance away from the center. So let's say this is the center of the cell. Then you have these 2 cells that are equal distance away, right? They are 1 cell away, and these 2 cells that are equal distance away. They must sum to the digit in the center cell. So these digits sum to that, and these digits sum to that. And those are the rules. So with that, let us start solving. So first I notice, well, this 15 cage looks very obviously suspicious, because the minimum digits you can put in 5 cells in a cage is 1, 2, 3, 4, and 5, which just so happen to add up to 15, and therefore it must be 1, 2, 3, 4, and 5. Now in each cage is also a zipper line, which says that the two digits like on equal length from the center must sum to the digit in the center. So what we're saying is that, where can 5 go in here? Well, if 5 was not in the center, it must add to something to give it the center cell. But the center cell, if it can't be 5, must therefore be less than 5, because we can only be 1, 2, 3, 4, and 5, which doesn't work because you have 5 plus something that cannot be less than 5, because we're all dealing with positive numbers here. So therefore 5 cannot be not in the center, and therefore 5 is in the center, which works just as well, because the outside values could be 1, 4, and 2, 3. Okay, what's next? Well, maybe the 8 cage, because the 8 cage must contain a 1. Without a 1, the minimum you can have is 2, 3, and 4, which add to 9, which is more than 8. So the 8 cage must have a 1 in it, and you can't have 1 in the center, because a 1 in the center implies that 2 digits sum to 1, which is not possible. So 1 is on the outside. Now what does that imply? That implies that the remaining digits differ by 1, because whatever digit you put that is not a 1, the next digit is 1 more than it, because there is a 1 on the opposite side. So what that means is that the remaining digits differ by 1, and without the 1 in them, must sum up to 7. So what are 2 numbers that sum to 7 that differ by 1? Well, the only one that works is 3, 4, right? Because 1, 6 is not allowed. 2, 5 don't differ by 1, so 3, 4 is the only one that works. And for 3 and 4, we already know that this digit must be the sum of the 2 outside digits. Therefore, the outside digits must be 1 and 3, which sum to 4. Now, it actually works a lot more. Yeah, it's actually even better for every line, because I can tell you what every line, or how every line works. I can tell you the center digit of every line, because every line, these 2 digits sum to the middle digit. Therefore, the total sum in this line is 2 times the middle digit. So for this line, for example, we can say that these 2 sum to that's 2 times of something, which sums to 12. So 2 times something is 12, and that something must therefore be 6, which means we can put a 6 down here. And we can do the same for the 10 here. This must be a 5, because that's half of 10. This must be a 7, because that is half of 14, and this must be 8. So now we can do the same for these lines, but they are slightly different, because we have 1 in the center, we have 1 set here that adds to it, and then a second set that adds to it. So the total sum of the full line is not 2 times it, it's 3 times the center cell. So we now know that this is 3 times the center cell, which is 21, and therefore that center cell must be a 7. For here it must be a 6, because 3 times 6 is 18, and here it must be an 8, because 8 times 3 is 24. And we can do the same trick for here actually, because if 15 divided by 3 is 5, so it has to be 5. Okay, we can do the same for 6 here, because these 2 digits must sum to Well, these digits must be the different ways to sum to 6, which can only be 1, 5, or 2, 4. Which means what? This cell? I mean, that cell could still be a 3 or 7. Maybe this cell. Right. Because this cell and this cell sum to 7, then this cell must be less than 7. But it can't be 1, 2, 3, 4, or 5 by all those cells here, so it must be a 6, which must have a 1 as a counterpart. So this now can't be a 1, therefore this now can't be a 5. These digits, well, they could still be 3, 4. No, wait. This 1 sees that, so that's 3. That's 1. Yeah, this could still be 3, 4. It could still be 2, 5. So that's fine. I don't think we can do anything with that. Maybe we can do this one, because these two sum to 5 and therefore must be about 1, 2, 3, and 4. This 6 sees those cells, well, it doesn't see those cells, but those must sum to 6 and can only be part of 1, 2, 4, and 5. This can't be a 5, this can't be a 1, and in fact, because 1 over here sees that cell, so it just has to be a 2, 4 pair. Fair enough. But what I wanted to say is that this forms a 1, 2, 3, 4 quadruple. Is that useful? No, of course it isn't. Why would it be useful? Okay. Let's see if we can do anything else. Yeah, what is this digit? This is less than 8. But can't be 1, 2, 4, 5, or 6, and therefore must be 3 or 7. This digit therefore must sum with this digit to be 8, so this must be 5 or 1. But the 1 here sees that cell, so that's 5. Therefore this must be 3. Oh, 3 in the corner. This can't be 3. That can't be 2, therefore. These two must also sum to 8. It could be 1, 7 or 2, 6, because it can't be 3, 5 anymore. This can't be 7, so that can't be 1. We're kind of stuck in a bit of a lull here. I can put those digits in. Those are 7, 8, 9. And in fact, 8 sees those digits, so 8 must be there. I can do the same here as well, I think. These digits are... whoa, what are those digits? 7, 8, 9 as well, and 7 sees both of those cells, so 7 goes there. This is 8 and 9. I can tell you those digits now. Those are 2, 3, and 5. And this 2, 4 pair sees those cells, so those cells are not 2, therefore 2 goes there. This cell sums with this cell to make 7, so this is either 3 or 4. Oh, sorry, 2 or 4. 2 or 4. Can we do anything similar? Maybe this one? This, well yeah, this can't be a 3, 4 pair because 3 and 4 see those cells. It can't be a 1, 6 either because 1 and 6 sees those cells. So this must be a 2, 5. Which means that now these can be 2. This cell now can be a 3, forming just a 1, 4 pair. And this cell can be a 6 because otherwise it would be 2. So this 1, 4 pair here sees that, therefore that can be 4 and must be 2. This can't be 1, 2, or 4, so it's 3. Therefore this is 2, therefore that's 4. We can remove 2 and 3 from those cells, forming a 1, 4 pair, which does out to 5. That's cool. Okay, this might take me a while actually. I don't know if it's because my brain is fried. In this one, 7 can't be in those cells. 7 goes there, meaning that's a 2, meaning that must be 6 to add up to 8. These cells are 1, 4, and 9. 4 sees that, so that's 1 or 9. This could be anything, I think. And then here we have 8 and 9 as well. Oh, sorry, the 8 sees that, so that's 9. That's 8. 4 actually sees that, so that's 1. That's 4. This is not 4. Okay, thanks for all the help, I guess. Alright, so these sum to 8. They can't be 1, 7, they can't be 3, 5, so they must be 2, 6, which we can resolve by this 2 up here. Those cells are 2, 3, 5, 6. But this cell can be 6. Again, thanks for all the help. This is 1, 8, and 9. 1 can't be there, so that's 8 or 9. This is 1, 8, or 9. Oh wow, so helpful. Okay, I'm pretty sure I was going to look somewhere else. This 2 sees that, so that's 5, that's 2. Now these cells can be 2. And this cell sees that, so this cell can be 2 either, meaning this is 2, which must accompany 4. So now these can be 4 forming a 1-5 pair, which is resolvable, and 1 and 5 do sum of the 6, so that's correct. That is, the 4 here sees 2 there, which must add with 5, so that's 3. These cells are 3, 8, and 9. Nothing. Wow. Okay, this can't be 8. That's all we get. Cool. Okay. I think I'm done with all the... I think this is regular Sudoku now, because I think we're done with every killer cage and every zipper line. So... just give me a while here. I'll figure this out. Maybe. Nope, just kidding. I probably won't. Okay, let's take a quick peek. Now there's a 6, so 6 goes there. 6 must be there in this box then. I think that finishes all the 6s. No, it doesn't. 6 is one of those cells, which forms an X-wing, which is very inconvenient. 3s. 3s in one of those cells. 3 is not there, which we should have seen by Sudoku. Whoa. 3 is in one of those cells. So this box, all of those cells are C, meaning 3 must be there. And then 3 here, well 3 here we don't actually know, 3 could be anywhere there. 7 in this box, 7 can't be in any of those cells, so 7 goes there. I think we can put those 2 digits down finally. Those are 9 and 4. This 1-4 pair sees that, so that's not 4, that's 9. That's 4. This 9 resolves this, 7, 9. This now also resolves that, so that's 8. This is not 8 or 9, that's 1. That's 9, that's 1. This makes this a 4, 1. Okay. Those digits are 7 and 8. 7 and 8, not resolvable, unfortunately. Here we have 2 and 4, which we can resolve. Then this is 3, 8, and 9. But in this row, 8 can't be any of those cells, so 8 must be there. That means that's 9, that means that's 3. Cool. So these digits are 3 and 9, which we can resolve by this digit up here. So that can't be 3. And this can't be 3 as well, I guess. Those digits are... Why I should look at this digit first. 1 and 9. 1 can't be here, so 1 is there. 9 is there. This makes that an 8. That's 9. These 2 digits are 5 and 8, which we also cannot resolve. Thank you. 4, 6, and 7. This can be 4, 6, so that's 7. 4 and 6. What now? Oh, 5. That can't be 5. Oh, chocolate teapot. Very nice. Thank you for that. We should probably look at this then. No. Really? Well, 1 in this box, right? 1 in this box sees all those cells. So 1 goes there. 3 therefore must go there. This makes that a 6. 5, 3. This 6 sees that, so that's 4. That's 6. This is a 9. 5 is in none of those cells, so 5 goes there, which resolves this. 8, 5. That makes this a 7, 8. Here we have 2 and... No, not 2. 4 and 7, which we can resolve. Solving the puzzle. Nice. Oh, this took more than 10 minutes, but I think a lot of it was just figuring out how these zipper lines actually work. And I didn't actually see the fact that zipper lines are actually, you know, different sets that sum to the same total. So a zipper line of this length must be 3 times the center cell. That was probably the most important part, which gave us like 9 whole digits to work with. So yeah, I think with that, I hope you enjoyed this puzzle. I will be seeing you now. Bye bye.